This is my first MATLAB tutorial in which I introduce you to some of the basics of MATLAB. With this mouse, I'm pointing out that right now this is the workspace. It tells me what variables are in memory and in some cases what values the variables hold and what type of variable they have. We'll come back to that later. This is the current folder. It tells me what's the path to the folder I'm in and what are the contents of the current folder. You can see here I have an illustrations folder, a distribution folder, and some files. And down here, this is the command window. This is where we type commands in MATLAB. So I'm going to start by defining a variable. Let's say a equals 5, and MATLAB returns this answer, a equals 5. I can press the up arrow and get the previous command. That's nice. And then I can type a new character. In this case, it's a semicolon. It redefines a to the same value, but this time it suppresses the output. And then I can also say b equals a plus 3, and then it evaluates b as 8. And then we can say c is a times b, and you can see, okay, it's 5 times 8 is 40. And if we go back to the workspace here, you can see I have these variables a, b, and c. These are the numerical values of those variables. And in MATLAB, most data is stored in a matrix because MATLAB stands for Matrix Laboratory. So A is a 1-by-1 matrix, as is B and as is C. So I'll define D as a random matrix, and I'm going to give it a 3, and that means it's going to make a 3-by-3 matrix of randomly generated numbers. So in a matrix, you can address each of the individual elements by row and column. So this is the first row, second row, and third row, and then the columns are 1, 2, and 3. So if I want the second row and third element of D, I type D open parentheses 2, comma 3. That's the second row, third column, and it gives me, yes, 0.5469, which is the second row and third column of D. I can also reference, for example, the entire second row of D. So I type 2 and then a colon, and that returns this whole second row because it specifies, this colon specifies all columns. So we go second row, all columns, and that's what we got here. Other data types in MATLAB are strings. So if I said x equals a, b, c in single quotes, it defines x as a character string, a, b, c. There also are cells or cell arrays which can store multiple types of data. So let's define M as a cell array, and we use braces to define a cell array. And the first element will be 1, and the second element will be x, and the third element we can even define an array. And if I hit enter, it tells me, okay, the first element is a number, second element that, it's x, and then this third element an array. So to reference the individual elements, I type M using these braces 3, and it gives me the array there, or M2, or M1. And I forgot about defining arrays. For example, if I said x equals 1:5, that gives me 1 through 5 integers. There's an array. Sometimes it's nice to make a vector that goes from one point to another and it's evenly spaced. So I can use the linspace command. And let's make one that goes from 3 to 7 with, say, 15 points. And if I hit enter, it returns these 15 evenly spaced points from 3 to 7 inclusive. Now the nice thing about MATLAB is that anything I can type in the command line, I can type in a script. So I'm going to hit this button, New Script, and it resized my workspace window and the command window. And now I have this editor, so I'm going to call my script something here. Like, we're going to call it myscript.m. And I just put that there in with a comment. This % creates a comment so that everything to the right of it is unrecognized by MATLAB as commands. It's not a command. And in here, I can define things. So let's say t equals linspace -1 to 1, and we'll say 201 points. And MATLAB has built-in functions, so I can define y as the cosine of 2 times pi times t, and actually I will uncomment these. I'll uncomment both of them. And if I hit run, well, it first wants me to save the script, so I'll call it, just like I said, I was going to call it my script, and I want to save it in a folder that's meaningful to me. So I chose, well, let's see, this is a folder I have for a certain class. So I made a MATLAB folder there, and I'll just call it my script. And if I don't put in an extension, it gets .m. And really, I want the .m, so I could type it or I could just leave it. In this case, I'm going to type it. Hit save, and the command, the file is my script, and I can run it by typing my script. MATLAB is case sensitive, so I have to get it right. I omit the m, the .m at the end. And for a moment, I'm going to make this window wider, and I'm going to run that again. And you can see here's the output of the commands in my script. So there's the y, and then right above it is this t. So we get to the top here, you'll see t equals all of this data. So now that we're working with this script, I'm going to show you some plotting commands. So we have t, we have y. I'm going to type plot t, y, and then I'm going to hit run, because I could invoke my file by typing my script again, or I can hit this run button, and you'll see that when I do, MATLAB puts my script down here. And this is what we get from plotting. We get the data is plotted with the x data and the y data, and those are specified by t and y. So to make this nicer, I'm going to hit this button here to dock the window. And that's not really where I wanted the window to go, so I'm going to grab the blue bar here and I'm going to move it around. I want it right in on top of that workspace. So now I can choose the folder, the workspace, or the figures. And so we have this plot, but it's not the nicest plot. I'm going to add some formatting to it. In fact, I'm going to first turn the grid on. Let's see what that looks like. Okay, that's kind of nice. I actually want to make the data line thicker, so I'm going to type line width 2. That's kind of a standard thing I like to do in all my plots. So that data stands out a lot nicer now. And I'm also going to make the font bigger, so I'm going to set GCA, and I'll explain what that means in a minute. And we're going to set the font name to times and the font size to 24. And then I'm going to run that again. And now you can see that things are bigger, more legible. And of course, every good plot needs labels. So X label, and I'll put in T here for that, and Y label, and I'll put in cosine of T, and I'll hit run, and you can see how that worked out. I have labels now, T and cosine T, but I want to make these symbols nicer because if you've read textbooks or whatever, variables often get italicized. So what I'm going to do is I'm going to enclose it in these dollar signs, and then I'm going to put interpreter and LaTeX here. And I'm going to run it, and you're going to see my T became italicized. So what I'm going to do here is I'm going to put dollar signs around the expression that I want to look like a math expression. And I'm going to copy and paste the interpreter LaTeX in there. And maybe I didn't like this one so much because it puts cosine T all together as cost. Now, if you're a LaTeX user, you know that you can type the backslash and then cost, and it recognizes that as a cosine function. Let's see if that happens here. I don't know. Yes, it does it very nicely, so it's cosine of T. Okay. Well, there's some basic plotting, but let's add a little bit more. Let's add a second line of data to this plot. Let's make y2 equal to almost the same thing, but now we're going to say 2 pi times cosine times a, where a provides some time scaling. And we're going to say, for now, we're going to say a equals 1. Time scaling factor. And we can even add a phase shift. And I want it to be in degrees, so to convert it to radians, because the cosine function needs radians. So I'm going to enter phase shift in degrees, so to convert it to radians, I multiply by pi and divide by 180. And we're going to put in a variable for phase shift. Phase shift, let's say for now it's 0, and I like to put in the units, it's degrees. And I guess one thing we could put in the scaling factor for A also, the units. The units are inverse seconds. So I can run this and nothing happened because I didn't tell it to plot y2. So to do this, I go to this plot command, and I'm going to change it a little bit. Instead of just plotting y, I have to put y here like this, y semicolon y2. And you might be asking why. Well, I will show you about that in a moment. So first I'll plot it, and now there's a red sinusoid that covers up the other one. But let's talk about what went on there with that semicolon. That is called the vertical concatenation. So, for example, let's say a equals 1 to 5, and then MATLAB puts it here, 1, 2, 3, 4, 5, and let's let b equal 6 to 10, and b is 6, 7, 8, 9, 10. Now, the vertical concatenation, or vertcat, is done using the semicolon operator. So if I say a semicolon b, then C becomes a new matrix that is the vertical concatenation of A and B. So I hit enter, and you see that my matrix C looks like this. Now I can also horizontally concatenate. So I say A space B, and I can hit enter, and then you see, well, now it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's all one row. Okay, so let's go back to our double plot. It's hard to tell, and you can't really tell that there are two sinusoids here. So what I'm going to do is I need to change the second line to maybe be a dashed line or something. And in order to do that, I have to create a handle to those lines. Now, I didn't do that, so what we're going to do is this plot command right here, we're going to make it an assignment. So we'll say my line equals plot. And so if I take away this semicolon, I'm going to hit run, and you're going to see that my line is an array of line objects. And that is how I can access these lines that are drawn here. So the first line that is drawn, which is y, the variable y, represents the variable y, or visualizes the variable y, is here, and the second one is y2. So I want to say, down here I want to set, and the set function requires an input, so I'm going to say set my line, and we want the second line, so we're going to set the line style to double dashes. And if I hit run, it's made the second line a dotted line. And just to clarify, I'm going to make my phase shift 90 degrees. And I'm going to run this, and you can see, okay, yes, there really are two lines there. So I'll make it 45, I'll hit run, bring them closer together, 0 degrees phase shift, and the two are one on top of each other. Another nice thing that I can do is I'm going to say my legend equals legend. So I use the legend function, and since there are two inputs, I have to assign the input to legend. So I've got two traces. I need to assign the input to legend to be two functions. So first is y, and then I'm going to do just like that. So $y, $, but I'm also going to put an underscore 2, and those of you who are familiar with LaTeX know that that's going to give me a subscript. The other thing I need to do is I need to set my legend, and I'm just going to copy and paste from up above here. I have to set its interpreter to LaTeX so that it makes it interprets these $ strings like text strings. So if I hit run, now I have this legend that tells me which line is which. So again, I'll put in a phase shift just to separate things out a little bit. 30 degrees. I'll hit run. And so there you have it. There is some basic plotting in MATLAB.